And hi, everyone. We're in our 19th session of the day. Here we are with David Belvins from Tommy Tribe. And David, do you want to take it over and tell us all about Jakarta Messaging 3.0?
Sure, absolutely. And, thanks everybody who's been hanging out all day. It's an incredibly long day of sessions, both for the organizers and the speakers. And it's really great if you're still hanging around this far after all that we've seen today. Okay, so I'll be presenting, a topic that's dear to my heart, which is Jakarta Messaging. So there's quite a long history behind this feature. And so I wanted to give some perspective on it. And it's one of those things that didn't, actually make the Java EE8 release before it was, basically stopped. So this is our chance to kind of, revisit something from the past and get it up to speed and take it a lot further. And so just before I get started, if you have any questions, please do ask them during the talk. Whenever you have the question, don't wait. I really enjoy when people ask questions, and it does help to keep the pace of the talk appropriate. So we have a very packed agenda here, and please do let me know if I'm losing you or you're getting confused. So a high level is we're going to take a look at where things left off in JMS 2.1. And how things are looking with what our options are for basically what is now called Jakarta Messaging under the Jakarta EE space. We're going to see what API options were there, what was the work in progress, and what could we possibly do with it in what we're going to call Jakarta Messaging 3.0. So we opted for 3 versus calling it 2.1 because the changes that we have in mind are just too large. So before we do that, the 2-minute perspective of JMS 2.0. So JMS 2.0 really tried to improve the kind of ceremonial requirements for creating and sending messages and both consuming messages. So here's what like a JMS 1.1 consumer would, sender would look like. It's a lot of boilerplate. We've got, some duplication going on here, and it's a little bit thick. We survived with this for many, many years, and then JMS 2.0 basically broke that down to be significantly smaller than it was before. We have the usage of auto-closable to make the trying with resources happen. And then once we actually get down to it, the true number of lines we need to send a message is about 2 now, with the 3 in the setup. So the change was pretty significant. This is also a builder API. So before we had to create all these objects, and if you wanted to set various options on them, you're looking at code like this. And now with the JMS context object that was added in JMS 2.0, we have it to be much more fluent. So everything, of course, is a builder fluent API, and we can get rid of all the variable declarations that we were doing before and just trim that down. Where this really paid off is when we compare something as simple as sending a text message. So in the past, you used to have to pass in the destination here at the top, here at the bottom. You got duplication, and you got in the middle some extremely mundane boilerplate for creating a simple text message. The Builder API now allows you to do that much more fluently, and so that's a great change that was made. It would take too long to describe all the changes that were put into JMS 2.0. But if I were to describe where JMS 2.0 left off and where JMS 2.1 was aiming to pick up from, is I would say in your head, you should imagine them as JMS 2.0 was very much a programmatic improvement of the JMS API. So when I say programmatic, I mean writing code at runtime in a method block. That code got significantly simpler. It added builders, it added the JMS context, JMS producer, and JMS consumer. And there was some improved CDI support in the way of allowing these objects to be injected. JMS 2.1 was aiming to do a very similar revamp, but adding annotation-driven perspectives on all these things. So where what you would do programmatically, you would instead do declaratively via new annotations that were to be added, and it was also had goals to add much greater CDI support. So it didn't quite work out. So in Java EE7, when JMS 2.0 was released, that was 2013, immediately afterwards, we started working on what was to be JMS 2.1. We had expert group meetings after Code 1 and so on and so forth. And we continued until the slowdown that happened that we're all familiar with, and JMS 2.1 was withdrawn 2 years later. We were 5 revisions into JMS 2.1, and it just, the plug got pulled. So of course, today, now we have Jakarta EE8 released. It's 2019, and we have the opportunity to pick back up where we left off in 2016 and finish 2 years worth of work that we did and add some new crazy awesome ideas. So let's get an idea of what it was that we were working towards in JMS. So before I get too far into that, there's a handful of ideas that we'd like to add on top of what we're doing in JMS. And these are the really cool ideas that, in my mind. So, obviously I spoke a lot about JMS 2.1 now, but I mean, I actually was presenting JMS 2.1 in 2014, 15, and 16. And so it's going to be a really great honor to finish that work. But now 3 years have gone by and we've learned a significant amount of things. So not only are we going to pick up where we left off in JMS 2.1, but we also have this kind of laundry list of possible crazy ideas we could add into something we might be willing to call Jakarta Messaging 3.0. So I'll get into these a bit later. But first, let's describe what it was, why it was important for us to add these annotation-based APIs. So here is a message-driven bean. This is the only annotated way to consume a JMS message in Java EE8 and Jakarta EE8. And there's several things that are wrong with it. I often feel like when we added annotations into Java EE and we made annotation versions of everything, MDBs were basically last on our list. In the EJB 3.0 expert group, we focused first on JPA and making that. JPA was actually built by the EJB expert group. Second order of business was making great versions of session beans. So we made annotated versions of session beans. And very, very last on the list was MDBs. And we didn't do such a great job when we did that. So here's a big problem with it. One, a user manual is required. So if you look at the top, they've got these strings, okay? We got property name and property value. And the issue with this is that you need to reference the documentation in order to figure out what properties can go in this annotation. The funny thing is that an annotation itself is supposed to be strongly typed property names and property values, but we have totally lost the advantage of annotations. We have a property called property name, and its value is a string, and another property called property value, and its value is a string. So we've totally messed up here. We have no way to actually know. And the other thing is that these are loosely typed. So here is a class reference in a string. Now, if we mistype that, it's gonna compile, but then we're gonna encounter a runtime issue if we mention a class that doesn't exist. we have a typo. This is the exact definition of a loosely typed language, and we should really be struggling to get this strongly typed. The other thing that's wrong with this is that I would describe it as poor targeting. So the configuration is at the top of the class, and we have it implicitly applying to the onMessage method, which is below. And because we only have one configuration at the top of the class, we can't have several onMessage methods. We have just the one. And so we end up with something that's very servlet-like in behavior. The other thing is message listener as an interface basically defines this one method and says all messages you consume have to come into you as message, and you need to do the boilerplate code to pick that message apart, figure out what kind of message it is, and go ahead and take action upon it. If we compare this to servlets, this is very much like if you were to do all of your modern API programming, all of your REST APIs in the servlet service method, right? It's ridiculous. But we still do this on the JMS side of the fence. And I think it's truly one of the reasons why it is so difficult to use. Is we've learned that you can't get by with one big service method that takes HTTP requests and HTTP response, and you've got to pick all the stuff out of it. It's much better that you have an annotation API that you can describe what you're after and have them basically hand it to you. So this is so 2004. All right, learning from JaxRS. JaxRS totally revamped how you consume HTTP messages. And instead of using Servlet API, you can use this API. It's got no interfaces. It's got full annotation-based API for describing what HTTP messages you want, passed into what methods you want. You can have several methods that consume messages, not just the one servlet service method or the do-get. And it's all very strongly typed. It's very self-documenting because if you want to know what options you have, you just go look in the JaxRS API and it has all the descriptors for you. It's got MIME types built in and everything. And so it is a significantly better API. And if we steal the concepts that JaxRS brought into HTTP and apply that to JMS, we get an API that looks basically like this. Instead of having one method that can consume generic message, we opt for an annotation-based API that allows us to declare several methods, okay? So this is significantly better. The top of this message has max sessions and max messages per sessions. Those could be those are basically equivalent to what are vendor-specific properties. The properties on top of an MDB could be a mix of standard properties and vendor-specific properties. So it made it truly difficult to know what could be placed there. And so this is where JMS 2.1 was headed. I'll take a look at that more specifically. And I have code up here in front of us to see. So I have a scenario, kind of a sample application. We're writing a build system. And in our build system, we're going to listen on a build queue. And when a build event comes in, we will take and we'll grab the project object as an object message. We'll do our build, which is just some boilerplate, which is empty down there. And then if it's successful, because it doesn't throw an exception, we'll go ahead and generate a success message that we throw on top of a topic, which is named right there. And we'll go ahead and if it fails, will throw a message onto the same topic, but with a fail status. First thing to notice, this is a new annotation. This was the equivalent. This would be how you would describe what is effectively the same as JaxRes at path. So this would be like the JaxRes at path. You could identify the queue that you wanted to listen on, give it a name, and then as messages appear on that queue, you would be called. Now, there would be some standard JMS message headers that you might want to use, and this is like the JaxRS equivalent of header param. Okay, so you can say, I want these things from the JMS message header, and there are standard headers in JMS, so you could pass in what you'd like. And one of them could be that you want the topic given to you. You've got the JMS correlation ID, which is something that can be supplied on the client side, and we're going to say that that's the build ID. And this is the project that we want to build, and then so we have our stuff. So the full breadth of annotations that we're slated to be added in JMS is 2.1 is here. So there's, of course, aside from queue listener, there's equivalent topic listener method. There's also message selector, which you could put below your queue listener or topic listener annotation and say, I only want messages that match this pattern. And some pretty basic stuff. So this is ultimately a pretty good API. It's fine the way it is now. So here's the consuming side of that thing. We have topic listener, which listens on our pass-fail notifications, accepts some other basic data. So this is a message property. Properties are basically like custom headers in JMS. And we have the ability to consume as many custom properties as we want. And then we have our basic boilerplate code of pass-fail. So the first thing that I think is kind of not so great about this is that message-driven is an EJB annotation. Okay, so if we were to make an improvement over what we wanted to do in JMS 2.1, here, let me keep this shared. If we were to make an improvement over what we wanted to do in JMS 1, I would say 2.1, I would say CDI consumers is a big thing for us to add. So why not have the ability to simply navigating with video is a little bit slower. Simply annotate our class with application scoped. We make a different annotation which identifies it as something that should be consuming messages. And very much like we can have CDI-based JaxRS endpoints, let's allow people to have CDI-based.
So there's a question here for you.
Absolutely.
Who is throwing the JMS exception in the notification listener?
All right, so let's go back. Who is throwing the JMS exception? That would be just part of the standard API. So you don't need it, and that's boilerplate that could be left out. So that's a good catch, and someone's paying attention at this late hour or early hour if you're in Japan or Australia. Yeah, so we wouldn't need to have that methods that throws clause there. It would be very much like in JaxRS, how you could throw a an exception, a strongly typed servlet exception or not. It would be optional. So we don't actually need that to make this code compile, and we'd be fine to leave it off in an API that we made final. So I'm going to actually check that change in. So thank you to whoever asked that question. Okay, so the simple change here is that we go ahead and make this application scoped. And now it is not a message-driven being, it is a CDI being. And as long as we're supporting application scoped, it should be possible to also support request scoped. So application scoped and request scoped are the two acceptable scope types for CDI that are allowed in JAX-RS, and we should be supporting them in Jakarta Messaging. And so, that is a very significant improvement right off the bat. The other thing that there's an additional thing that I don't quite like about this is that we have these ability to specify all these different properties that we want. But if we look at JAX-RS, we can have strongly typed objects as header params and path params and query params, and JAX-RS will figure it out. We don't have to be stuck to just string, int, and Boolean and the primitives, right? So that would be the next thing that we would do, is we would add equivalent property conversion into the API. So instead of doing code like this, we could have significantly simpler code like that. Instead of a build ID string, we're going to make a build ID strongly typed object. Okay. Instead of having date as a long, let's have an actual date object. Instead of passing in project URL, which is obviously not used, but for the sake of an illustration, it's fine. We'll take a URL. We'll take a URI for the build URL. And for build status, a simple enum of pass and fail, right? So now we're no longer doing string checking here, which is extremely error prone. If we look at the way we were doing it before, I mean, this code is very susceptible to breaking. And so by making things strongly typed, we actually can improve the API usage significantly. So we're good. This is already an amazing set of improvements. But I think we can go much further, right? So there's been a topic that I've really talked about at conferences in the past a handful of times, and we never actually managed to get too far with it. And that is the concept of meta annotations, or what CDI has, it's called stereotypes. Stereotypes are the first thing that we can do to really cut down some of the boilerplate that we have, even with this simplified API. So if I were to go back to this particular thing here, and we're to see this. Now, I personally think that is way too long. I don't particularly enjoy having to use the message header annotation with a very, very long standard parameter. CDI's stereotypes allows you to basically inherit annotations on other annotations. So if we added CDI stereotypes into Jakarta Messaging as a natively supported thing and took advantage of it in the Jakarta Messaging API, this code, and I'll see if I can do this quicker, turns into that code, significantly smaller. How did we get this to work? Well, ultimately, what this proposal would entail is that we have in the Jakarta Messaging package right here, and this would obviously have to be Jakarta, not JavaX. We have a standard @reply to annotation. It's marked as a CDI stereotype. and it uses the message header annotation and passes reply to. Specifies that we can have this on another annotation type or parameter, and then there we go. We've gone from that to this. So we're starting to inch our way into something that's really getting more usable and not too bad to look at. So if you can have standard annotations, if the API can have standard stereotype annotations, that's great for when there are standard header parameters, but message properties are of your own creation, right? So that still leaves you with this kind of garbage here at the top. If we were to apply the stereotype concept to message properties as well, and while we're at it, why not to this? Basically anywhere that we have a string that might get copied and pasted and typed wrong or made a maintenance nightmare, let's put that into a stereotype and make it reusable. So the better way to do this is like that. Oh, this is not the right one. Hold on, let me see if I can find it. Okay. We're just gonna, that's the one. Okay. So the better way to do it would be like this. Let me close this down here at the bottom. So if we had the ability to use stereotypes in our own code, we would take that boilerplate and we would put it here in the stereotype annotation, and we ourselves are defining our own stereotypes. So we got org example properties, and we can have all the different application headers and things that we want to pass around standardly defined ourselves in our own code, and then reused in our own in our own consumer methods. So JaxRS doesn't actually have this concept because its integration with CDI kind of stops at allowing you to declare that your bean is a CDI bean, but JaxRS does not try to unravel the CDI stereotype magic to figure out, are there JaxRS annotations that I should be concerned about used in these CDI stereotypes? So it's a very significantly underused feature of CDI that I would really like to see Jakarta Messaging be one of the first brave specifications to actually go, you know what, that feature is amazing. It could really cut down on the boilerplate. It would keep us from copying all of our annotation data all over the place. We could make all of our annotations all strongly typed, no string parameters. And if at some day in the future we want to rename what the property is, we change it in one place, and all the code that references this strongly typed annotation will magically be right. Imagine how your life is now with JaxRS, and you want to change the name of a path parameter. That will take you forever, and you better hope you have great tests because you're going to miss a couple. A string find and replace is not safe. It is very, very, very hard to maintain when you have a lot of it in your code. So that right there is a very huge change that we could take advantage of to make the Jakarta Messaging 3.0 significantly better than even JaxRS. So there's a certain point where this API potential catches up to JaxRS, and then there's a certain point where we start going way beyond. And this is one of those areas. So another thing that I still think is wrong with this code, if we go back to this where I left off, we're still doing some things that I don't particularly care for. That's this line right here. We're taking object message as a parameter, and we are casting it to project. One, this is boilerplate code we should avoid. Two, I would really like to have project be a parameter here. But three, I don't want it to be a binary object. It should not be serialization. If we're still passing around serialized objects because we're using JMS, it is a huge, huge no-no. Serialized objects are very, very brittle. If you change the class definition in certain ways, it will totally break the ability to deserialize. And since we have data that's inherently distributed and asynchronous, it could take a long time to be consumed. It could sit in a queue or a topic for a while. It is a very, very dangerous thing to be doing. So a lot of us are passing around text message, and we are putting XML data in there, and then we have to use JaxB or something of the sort to marshal that. So that adds to the boilerplate code that we have. Again, JaxRS simply says, if you have MIME types and you tell me what you want, what you're giving me application JSON, I'll use JSONB to marshal that. So let's add very similar things to the Jakarta 3.0 messaging API. Add JSONB integration so that we can pass JSON messages around and have them consumed, by our various code. And so if we were to take a look at what this would look like, easier to go this way. Okay. So now we have project as a parameter. If we take a look at it, it's got JSONB property order on it. It's got JSONB properties. And so we're going to assume that the message that we get is a text message and that it can be marshaled to something from JSON into this. And then basically the JMS connector that drives all this would figure it out, just like JaxB does, just like JaxRS does. One of the tricks to making this work, which was something we need to solve, is HTTP has explicit content types. And so we would need to add a very similar type of concept into JMS so we could communicate in an outgoing message what type of content is in that. If it's a text message, is it application JSON? Is it application XML? Right now, there's no standard header for that. So we would need to add a standard JMS header that could basically be something like content type. And so that would be one of the necessary tweaks that we would have to do into the JMS API itself in order to support the idea that we could use JSONB and, of course, perhaps JSON JaxB for XML version to do that marshaling. But if we do, the payoff is quite significant because now we no longer need to be accepting just simply one of the 5, 6 different JMS message types. We can actually accept strongly typed objects and cut that boilerplate out of the middle of our implementation code. And so that would definitely improve things significantly. Now, we're still looking at something I think is a very big anti-pattern. I personally think this is way too much code for sending messages. We have this nice new annotation-based API that allows us to describe in annotations how we want things basically moved into our code. The JMS message disappears, and now we're dealing with project. And so, you know, we're telling the JMS implementation, or now the Jakarta Messaging implementation, just like JaxRS, give me my code. Don't give me the objects that you want. And so that's great for the consuming side, but on the producing side, we're still dealing with the boilerplate API. And so this is sort of a newer concept, and I don't know if you're familiar with the micro-profile REST client, but if you're not, it's incredibly clever. So I have a quick example in a blog post to show you that effectively looks like this. So let's imagine that we have... Yep.
I'm sorry to interrupt, but there is a Hansi Bai here is asking a question. Message property is part of the message payload or headers?
So it is, JMS messages are in 3 parts. So there are effectively message headers, which are basically like standard HTTP headers. They're clearly defined, and they exist as metadata outside the message body. Message properties are like user-defined HTTP headers. Imagine in HTTP you have X dash and you make up something. That's effectively what message properties are, and they also live outside the body. And so you have effectively the 2 classes, headers and properties, and then the payload. So it would be possible for us to have a standard header introduced called content type, and it would never conflict with any of your existing code that might have had a message property called content type, because unlike HTTP, JMS actually has the 3 things, not just 2. HTTP has all headers and then the body, and your headers and the standard headers are mixed together. And in JMS, you have a distinct section for standard headers, another section for user-defined, what they call properties, but they're basically headers, and then the payload. So does that answer the question? I usually get a nod if I'm speaking to a live audience, but we don't get that benefit. So I'm gonna assume that does it. An interesting thing about message properties and the message headers is that both of them can be used in JMS selectors. So a selector is basically like a SQL query statement for JMS messages, and you can do evaluations on either JMS headers or JMS properties. And you can say things like, if the property name is here and it's an int greater than 0, I want that message. So they're pretty cool. Okay, so back on to the concept of how we might reduce this boilerplate code. And so we're on to the last section of this. And I hope I'm not going way too fast. It's one of those things when you don't have a live audience in front of you, you don't see the confused looks on people's faces to know to stop and explain something a little longer. So, you know, I'm available for questions now. Please do ask them now. And of course, we can have some QA at the end of the session as well. And then, of course, there's Twitter. So, so back onto this. So microprofile introduced a concept which is basically strongly typed clients. And it takes advantage of the fact that JaxRS is ultimately an incredibly strongly typed API of your design. You simply describe your API using JaxRS annotations, but it's largely your objects going in and out. And so what JaxRS says with microprofile REST client, this concept it adds, it says, let's say you have a JaxRS application, a REST endpoint that looks like this. It's got movie find. Movie can be marshaled with JSON-B, so it's application type JSON. It takes a path param of long, which could be the ID of the movie that you want, and it does a simple find and returns it. It responds to messages on the path endpoint, and if you have the ID as a subparameter under path, so movies/ID, it's going to go ahead and do its thing. Now, many people are using various HTTP clients to call code like this, but you're dealing with a standard HTTP looking interface when in fact, if you take away these annotations, what you have is just a basic Java object. And so the microprofile REST client says, let's take advantage of these annotations that are describing in great detail how the message needs to be taken apart, pushed into the various object types, and given to the class. Let's do the reverse on the client side. Take the same annotations and use them to build an HTTP message. Then we'll send the HTTP message under the wire, and the caller does not have to be aware of it. So the rule is you simply annotate an interface of any name with JaxRS annotations. Ideally, they will match your REST endpoint, but they don't have to. They just need to be good enough to build an HTTP message with. And then you pass that interface into what is effectively a builder. So you have REST client builder. It takes movies resource client, and then in one line of code, you're invoking your REST endpoint in a strongly typed fashion, not seeing a single bit of HTTP message. So this is an amazing concept that is something we could potentially use right here. Okay? So if we were to take advantage of that and add a messaging client, okay? This is a very, very, very thin example. We would need a lot more to this interface, but ultimately, here's how it would look in practice. Build and notify now no longer has that big thing where we're dealing with the JMS message producer and the builder and all the various things. Instead, we would simply take, just like with a microprofile REST client, we would go something like messaging client builder, new builder. We would pass in perhaps the connection factory that we got injected, so we don't have to do any plumbing. We'll just say, here's the JMS broker I want you to talk to, and then give me a strongly typed view on top of all the topics and queues as defined by this interface. And if we look at it, basically what we'd have is something that's an interface version of the listener code that we've been looking at the entire time. So it has the same annotations that we're using to consume messages. We put those annotations on an interface, and now we have an annotation. Now we have an annotation-based API that allows us to describe how we want messages sent. And so we pass in that class. We get an instance of it back, which is now effectively going to be a proxy. This is a magical piece of code that like an EJB proxy. Maybe a bad comparison, because maybe some of you just thought, oh, ick, now I don't like it anymore. But that's okay. And so now we have an instance of this interface that's created by the messaging client implementation, which would be your JMS provider. And once we have that, now we are sending a JMS message in plain Java code. And I cannot stress how cool that is, because basically we have improved the JMS API 3 times, and still it's a little bit clunky. In JMS 1.0, we had a very verbose way of sending messages, and in 1.1, we cleaned it up. And in 2.0, we cleaned it up further, but it still doesn't quite feel like regular Java code. It still feels like I'm sending a JMS message. So what is your first instinct as a developer? You're going to abstract that out. You're going to put all that code into a wrapper, which you give to everybody else, and then they can call your wrapper. Your wrapper will build the JMS object, do the marshaling of things from an object into JSON. It's going to create a text message, and it's going to produce a text message with the JSON in it, and then it's going to send it on a queue that's got the name that you give it or the topic, and it's going to do lots and lots of boilerplate. So we would have effectively created an API where all the boilerplate is gone when we consume a JMS message. But when we want to produce one, all that boilerplate is still there. And that is the kind of genius that the microprofile REST client adds. It says these two things are two sides of the same coin. That definition that describes the server side can be the definition that describes the client side, because they're both supposed to match up. And so if we take that perspective and we add it into messaging along with the improvements that we want, we end up with a strongly typed sending API and a strongly typed consuming API. And if we look at how all these things look and feel together, our total set of improvements basically boil down to this. Whereas before, we had a pretty significant amount of garbage going on, we've now shrunk it down to the most minimal piece of code that you could possibly have. I guarantee this is absolutely different than anything you're looking at with JMS right now. And if we were to get these improvements added into the Jakarta messaging, I mean, maybe 3.0 isn't a big enough version number increment. Maybe we need to call it 4 or something like that. But it would be truly awesome. And so, the full set of things that we could add into Jakarta Messaging 3.0 is extremely impactful. It's difficult to enumerate the various ways that it would be awesome. And that brings me, to the final thing, is that this is a bunch of crazy ideas, and none of them are real. And when we go to do these, your input is absolutely necessary. To make this stuff happen, we need people to show up on the mailing list. We need people to get involved. We need people to give their best ideas on how to improve this stuff. We need people to say, I like this idea, or I don't like that idea, or of all the things that you listed, this one is the coolest, or that one would impact me the most. Because this is a lot of potential improvement, and there's going to be an enormous amount of work writing TCK tests for all this, an enormous amount of work doing specification documents to describe all this, an enormous amount of work creating how-tos and examples for all this. I haven't even described the work to implement this stuff. So the work that we could be doing together to make this real is quite a lot. And so, what I would say to everybody is take a picture of this slide. Let's get you on the JMS message list right there. Follow the JMS API Git repo. And if you want to see any of this code afterwards or take a look at it, it's currently sitting at this repository. This is a temporary location. All these ideas, we got to get moved into the Jakarta Messaging project itself. We've just been so hands down on getting Jakarta EE8 out the door that, whatever we could do to get this stuff just written down is what we did. But ultimately, this is all needs to go into the Jakarta Messaging project. And, all of us together really need to work our butt off to make this stuff real. Ideas are cheap, and they may seem impressive, but until someone puts the work in, they're just ideas. It's just a slide. You can't run a slide. So if you really want to be involved in making one of the first very, very revolutionary changes into Jakarta EE, I think that Jakarta Messaging is a great place to have a major impact. And so please do show up on the list. And I am done with my time. And so if there are no more questions, then are there any questions, Tanya? I'm going to assume that's no.
Thank you, David.
Okay. And then, I hope people enjoyed, and please do jump on the mailing list, and I hope to see you there.
Okay, so let me just see the last question that we have here. Would the notifications client interface benefit from being a functional interface?
It potentially could. It potentially could. I mean, I don't have any ideas baked in advance that would take advantage of that. Certainly, certainly there are plenty of functional opportunities in messaging in general, right? Instead of having annotation-based, functional opportunities could, there's a lot of functional opportunities that are different than the annotation-based versions, right? So in an annotation-based API, you say, there's my method, you go find it, and I've described to you how I want you to call it. And in a functional world, you build up in code, you pass in the method reference, say, don't find it, here it is, I'm giving it to you right now. Call that when all the things that I've built up here happen. And so there is definitely an opportunity for functional APIs in messaging and definitely in Jakarta Messaging. And I don't have any of them baked up right now. And that just goes to show why it's super important to have many, many people on the project thinking about all the different ways that we can improve the messaging API. And so I would say that's a fantastic suggestion. And I would definitely hope, I don't know, I can't quite see who asked it. Hanson. Yeah. So I really hope to see you on the list. And if you have any kind of thoughts on how that might look, I would really love to see them. And so, definitely do come over and say hi, and even if it's just a question, maybe somebody else has an idea on how to do it, right? People underestimate the impact of a really good problem. I actually have a philosophy on problems that the more vividly you describe the problem, the better the quality of the solution that comes around later. And so if you have a specific use case in mind, that's really the best thing to bring to the project. So you may not have the best solution, but if you have the best problem, you win. So definitely do come to the list and talk about the things that are difficult for you now and that might potentially be better for you. But I hope that makes you feel encouraged to jump in. So.
And then there is another question. Message selector is some like MPQP exchange?
I'm not terribly familiar, but I will simply say message selectors predate AMQP. And so, AMQP came along later, and so there will definitely be some representation of them in AMQP, but I'm not an expert in that protocol to be able to answer the question. I would just simply say that in the original JMS API, when you're building up your consumers and things like that, you can say in a SQL-like syntax, select me these messages, yes, I'm listening to this topic, or yes, I'm listening to this queue, but I only want messages from the queue or topic that match this pattern. And it allows you to basically specify, filters on top of the message properties and message headers. So I don't have the specific answer to that question, but I hope I've described it more vividly for you to imagine how they work.
And there is a last one. Would the JMS 3.0 reference implementation start with open message queue?
I don't work on OpenMQ. So, Tommy Tribe commercially supports ActiveMQ. We have a number of customers who use ActiveMQ, and Tommy uses ActiveMQ, and it's an Apache project, and Tommy Tribe supports basically everything Jakarta EE that's Apache. And so I personally wouldn't be doing any implementation work over in OpenMQ. And just FYI that Jakarta doesn't have reference implementations anymore. So Jakarta is a competitive space where an idea is thrown out, and the first implementation to pass the TCK for that idea, that's enough to call the specification finished. There may be 2 implementations, or 1 implementation, or 4. And so there is no, this is the one special implementation that's a little bit more equal than all the other implementations. And so, people are definitely welcome to go contribute these types of concepts into OpenMQ. I'll be working on ActiveMQ. And so, whichever one you like, go ahead and contribute.
Thank you, David, so much. And as always, we enjoy your sessions, and I'm sure we'll be in touch in the future as well. So at this point, I will invite people to join us in the next session, and I'll let David log off and get some rest. Okay.
Great to see you, Sam, by the way. I noticed you in the chat. Thanks for the question. All right. Thanks so much, everybody.
Bye, David. Bye, everyone. See you in the next session.